What's up guys, welcome back to the channel. In this particular video I will explain the problem binary tree to BST. This problem is very important guys and frequently asked by companies like Amazon and Adobe, so make sure you stay tuned till the end of the video. Starting with the problem statement, so it says that you are given a binary tree. You have to convert it into a binary search tree in such a way that keeps the original structure of the binary tree intact. Okay, so we are given a binary tree. We have to convert it into a binary search tree and we have to maintain the same structure as given of the binary tree, right? So one example is given here guys. Let me explain using this example. So I have to convert this particular tree into a binary search tree and I have to maintain the same structure. So first of all, let me write this structure. I have this structure, right? For a binary search tree guys, we know one thing, that every value on the left side or the left subtree is smaller, right? So let me write smaller here, and every value on the right subtree is greater, so I'll simply write greater here. And now guys, what are the values which are given to us? I have 1 2 3, right? So all the values are which are smaller on the left hand side and all the values which are greater are on the right hand side, right, or the right subtree. So what I'll do is I'll simply write the middle value as the root. So this is the middle value and all these are smaller value, all these are greater value, right? So I'll simply write the middle value as the root, and all the smaller values are going to be a part of left subtree, so I'm simply going to write 1 here, and all the greater value are going to be the part of right subtree, so I'll simply write 3 here. Now guys, this particular tree is going to be the binary search tree. You can see one thing, that we have the same structure as given of the binary tree, right? So guys, this is going to be the output. Now I hope you have understood the problem well, so let's talk about the solution now. Okay, so I have written one example here, and guys, I'm going to use this particular example in order to explain you the approach. According to the problem, we have to convert this particular binary tree into a binary search tree, right? There is something special about a binary search tree, guys. We know one thing, that in order traversal for a binary search tree is always sorted. Let me write this. So in order traversal is always in sorted order, right? If you are someone who don't know this particular property, so let me explain in brief guys. See, I have written a BST here, and for a BST we know one thing, that every value on the left side are smaller and every value on the right subtree are greater, right? And whatever is my root value is going to be the middle value, and we are going to perform the in order traversal for this particular binary search tree. And guys, if you don't have any idea, so it is going to be a prerequisite that you should know about in order traversal. I have written a pseudocode here, and see, for in order traversal we first start with left subtree, right? So we are first going to print the left subtree, and when we print this, so I will have all the smaller values first. After this I will print the root, so I will have middle value on the middle. After this I will go to right subtree, right? So I will last print greater values. So now you can see that first I have smaller values, then I have middle values, then I have greater values. So guys, this is nothing but the ascending order of elements, right? So in order traversal for a BST is always sorted and in ascending order. So now I hope you have understood this. Let me talk about the approach guys. See, I want you to watch everything carefully now. What we can do is we can store the in order traversal for this particular tree first, right? So what is the in order traversal for this tree? I have already written the pseudocode guys, right? This is the pseudocode. First we start with left, and we keep moving to the left node until we reach a null node, right? After this we print the root and then we move to the right subtree. So what I'll do is I'll start with this particular root. After this you can see that I have a left subtree, so I will move to left. I have again a left subtree which is here, so I will move to left. And now guys, you can see that there is no any value on the left side, right? So I will stop moving and I will simply print the root. So I will have 4 first. After this I will simply backtrack, because this is how the recursion works, right? I am done with this particular node. Now I am at 2 and I am done with the left subtree, so I'll simply print this particular node 2, so I will have 2. After this I will move to the right subtree. I'm actually first I'm printing this particular subtree, which is the left subtree, right? So after this guys, I will simply print this particular node, which is 5, and now you can see that I have printed the whole left subtree. After this I will backtrack and I will come to this one and I will print this one, right? This is how the in order traversal works. After this you can see that I have printed this node as well, and I'm only left with the right subtree. So for the right subtree guys, what I'll do is I'll simply move to right, because I am done with left part, right? After this I will move to left part of this right subtree. So because I have not printed this particular part, right? After this guys, you can see that I have 6 and I have no any node on the left, so I'll simply write this 6. After this I will backtrack and I will come to 3 and I will write 3 here. After this I will go to the right subtree of this particular subtree, right? And guys, you can see that I have a node, so I'll simply write a node here. Now you can see that this is very similar to what I have explained. We have left subtree first, then I have the middle value, then which is the root value, and then I have the right subtree, right? So this is the in order traversal for this particular binary tree. Now guys, I know for a BST the in order traversal is in sorted order, right? So I'm simply going to sort this particular list. So first of all I'm going to have 1, after this 2, then I will have 3. After this guys, what value I will have? I will have 4, then I will have 5, then 6, then 7, right? So this is going to be sorted in order traversal, right? Now guys, see, let me write in order first. So we have sorted in order traversal, but for this in order traversal we don't have a tree, right? So we are going to form a tree out of this particular traversal. First of all, we know one thing, that we have to maintain the same structure according to the problem, right? We have to keep the structure intact. So what I'll do is I will simply draw the structure first. So I have a structure like this, right? This is the structure that we have for the input, and what I'm going to do is I'm going to perform in order traversal for this particular tree, which is the same tree, right? I'm going to perform the in order traversal for this tree, but first of all let me erase every extra stuff that I have written here. So I'm going to erase everything from this particular tree. And now see guys, what I'll do is I will perform the in order traversal in this tree again, right? And while performing in order traversal, I'm simply going to replace the values. See how? First of all I have 1, so when I perform in order traversal, so I will write 1 here, right? Because this is the first node that we go to. After this I have 2, right? So I will write 2 here, then I have 3 here, so I will write 3 here. After this I have 4, right? So I'll write 4 here. After this I have 5, so I'll write 5 here, then I'll write 6 here, and then I'll write 7 here. So this is the new binary search tree that we have. I have 4, then 1 2 3, and then 6, then 5, then 7, and this particular binary search tree is going to be the output for the given input binary tree, right? Now guys, I hope you have understood the approach. I am going to write the steps for the algorithm. See, the first step is store uh, in order traversal for the given binary tree, right? So in order traversal for given binary tree. So let me write input tree here. So I'm simply going to write input tree. This is the first step that we need to do. After this, the second step says that sort in order traversal, right? This is the second step that we have in order. Let me write array here because we are storing the in order traversal somewhere in an array or a list, right? After this, the third step is like simply replace the value in the binary search tree while performing the in order traversal, right? So replace uh, tree value tree values with those present in the array, right? Those present present in array. So this is something that we can do, and we have to replace while performing the in order traversal guys again. So we have to perform in order traversal 2 times, and this is the whole idea that we have. Now I'm going to write the pseudocode guys, so that you will have complete idea about how it works. So what I'm going to do is I'm simply going to erase this particular part guys. So I'm simply going to erase this particular part so that I can get some space to write the pseudocode, right? What we are going to do is, okay guys, I'm not going to write the in order traversal again and again. I have given you the idea about how in order traversal works, but I think I need to write this because we are going to change something in order traversal, because I'm not going to use the exact in order traversal. What I'll do is I'll first have a list. So let's say this is our function which we have to write in order to get the answer, right? This is our function, and this function is obviously going to give us a root as the parameter, right? And what I'll do is I'll first declare a list. So I'm going to have a list, and this list is empty, so I will call a function in order, and this is going to take root and the list guys. We need a list because we are going to store the in order traversal for this particular tree in the list, right? Now I will have an in order function, so let me write in order, and this in order is going to be very similar to this particular in order function. So I'm going to close this function, and guys, you can write this particular function instead of this like in place of that particular function, right? How you are going to use, we are going to have a list as a parameter, right? And guys, instead of printing the root, I will simply do list dot add root element, right? And this is how I can get every particular element in the in order traversal in this particular list, right? So now I have a list. I have a list and this particular function is present below, right? Now guys, see, I have the list, so my second step says that sort this particular list. So I'll simply say that okay, list dot sort, right? List dot sort. And once the list is sorted, so what I'll do is I'll simply call a function which is convert, and this particular function is very similar to this particular in order function, but there is a difference. See, uh, what is the sorted order we have of like this particular in order traversal list? So I have 1 2 3 4 5 6 7, right? And I'm going to replace every value in the in order traversal with these values, right? So I need a pointer. I'm going to have pointer I equals to 0. So what I'll do is I'll simply pass root, then I will pass the list, then I will pass I equals to 0, right? But guys, make sure that this particular variable should be a reference variable, because I want this particular variable to change when I change in the function, right? So this particular function should be a reference variable. Now I'm going to write the convert function, and once we have done the convert function, then we are simply going to return root, right? I will definitely show you the code as well, guys. This is just the pseudocode and the idea behind the approach. So now I have the convert function, I have convert, and this particular function will do nothing but perform the in order traversal again. So I have root, then I have list, then I have a reference variable which is I, right? After this, guys, see, if my root is equal to null, because this is how we write the in order traversal, if my root is equal to null, uh, then I'm simply going to return, right? After this, first we go to left, so I'll simply call the convert function for root dot left, right? Root dot left. And guys, I'm not going to write these particular parameters again and again, because this is a kind of pseudocode, right? After this, we convert, like we call the convert function for right, but between this, uh, before we call the convert function for right subtree, we do something here, right? This is how the in order traversal works. First left, then we are going to perform some step here, and then we will go to right. So between this, guys, what I'll do is I will simply replace the value. So I'll say that root dot data is going to be equal to list of list of I, isn't it, guys? So this is something that I will do. After this, I have to increment this pointer as well. Like, first we go to this 4, and then we simply replace this value with 1, because I have 1 here, right? After this, I will increase the pointer, because whatever value is the next value, I have to replace that value with the next number in the list, right? So I will simply do I plus plus. I know this is not very clearly visible, guys, but I will definitely show you the code. This is the code, guys. Let me show you the C++ code as well. So this is the C++ code that we have. And now, guys, you can see that we have two functions which are very similar, but there is a small difference between two functions. Both are in order function, but in this function I am storing the values in the list, and in this function I am replacing the value in the binary tree, right? So that I can get a binary search tree. At last, I just need to return the root. I have written the same code in Java as well, and we have the same code in Python as well. So guys, now I hope everything related to this particular problem is clear to you, whether it's the algorithm, or it's the approach, or it's the pseudocode, or the time complexity, or the code implementation, right? So this is all about this video, guys.